What's the brightest bang in the universe, and could it hit us? Welcome back, cosmic explorers. Today, we're blasting into gamma-ray burst, the most powerful explosions since the Big Bang. Buckle up for a wild ride through space's most dazzling fireworks. Gamma-ray burst are short, intense blasts of gamma rays. Light so energetic it outshines 1 trillion suns for a few seconds. They come from two main culprits. First, the death of massive stars, 20 to 30 times the sun's mass. When these giants run out of fuel, they collapse and explode as hypernovae, firing off gamma-ray burst along their spin axis. Second, the collision of neutron stars, those ultra-dense remnants we've talked about before. These mergers, like the ones that ripple gravitational waves, can trigger gamma-ray burst too. Rare? Yes. Only about 1 per galaxy every million years. But when they hit, they're unstoppable. So, how do we catch these cosmic cannons? Enter the Fermi Gamma-Ray Space Telescope, launched in 2008. It spots gamma-ray burst across the universe, pinpointing their locations in seconds. Some last milliseconds, short gamma-ray burst from mergers, while others stretch to minutes, long gamma-ray burst from hypernovae. Their afterglows, in X-rays and visible light, let us peek at galaxies billions of light-years away. Take gamma-ray burst 080319b in 2008. So bright, it was visible to the naked eye from 7.5 billion light-years. That's halfway across the observable universe. Talk about a cosmic spotlight. Now here's the kicker. What if one went off nearby? A gamma-ray burst within a few thousand light-years could strip Earth's ozone layer with gamma rays, letting in deadly solar radiation. Luckily, the closest candidates are tens of thousands of light-years off. Still, it's a reminder of the universe's raw power. Scientists think gamma-ray burst might have shaped life's evolution by occasional sterilizations in the past. Could one have zapped dinosaurs? Pure speculation, but it's a fun thought. Gamma-ray burst are nature's loudest messengers, teaching us about star deaths, neutron star collisions, and the early universe. They're fleeting but fierce, and their afterglows unlock cosmic history. From hypernovae to mergers, they're a violent link in our astrophysical chain. Want to dig deeper? Check the links below for more on Fermi and gamma-ray burst research. Keep looking up, explorers. If you like this cosmic blast, subscribe and hit the bell for our next dive. Tomorrow we're echoing the Big Bang with the cosmic microwave background. See you then.